Hello. Water flowing in a conical container at rate R, and this container has the shape of a right circular cone shown here below, and it has a horizontal base with a vertex pointing downwards. So this is the vertex pointing downwards. The horizontal base is at the top. The radius of the base is A, as you can see. The altitude or the height of the cone is B, here, shown here. And we need to find the rate at which the surface is rising when the depth of the water is Y. So the depth is at this level here. And we need to calculate the value of the unknown. So the unknown here is the rate of change of Y. We want to know how this changes the height Y, which is, or the depth of water, how it changes. Now, the derivative is the rate of change of Y, which is the rate of change of a function. So Y increases as time increases. So Y increases over time. Let's make that yes. And we can write that as dy dt. Next, we need to express dy dt in terms of A, B, R. So in terms of A, which is the radius of the base, B is the height of this container, R is the rate, and Y is the initial height of the water in the container. R is the rate at which water flows into the container. That is the rate of change of the value of water in the container. So I'm going to be doing this in a number of parts. This brings us to the end of part 1 of this video, or of this problem. And I'll continue in part 2, and then finally in part 3. Thanks for watching. I'm Alistair.